Hello and welcome everyone to my YouTube channel, and today we will continue our Docker learning series. In the last video, we talked about the different types of Docker network and how it enables our containers to communicate with each other and to the internet. And in this video, we will talk about the various Docker storage options. We will specifically talk about Docker volumes, which allows us to have persistent volumes and storage for our containers. We will see how we can create a volume, how we can inspect them, and how we can attach or mount it to our containers so that our containers have a dedicated storage area where they can persist the data that they need, such as for database and other things. So without further ado, let's get started and explore the world of Docker volumes. Alright, so before we get into the demo, let us try to see the various Docker storage options. So in Docker, mainly there are three types of storage: the Docker volume, the bind mount, and DMBFS. First, let us talk about the Docker volumes, which are the persistent storage options. So if you want to have a persistent data for your containers, let's say your database container, then you can use the Docker volumes. So it utilizes Docker volume driver, and there could be different type of Docker volume drivers. You could have a local driver. So that means that all the data that the container wants to persist will be stored in a dedicated area in the host. So we could have a specific path where the volume data will be stored. And we also have volume plugin, and this plugin allows us to use external storage such as storage in the cloud, such as Amazon EBS and some other storage options. So if you want to attach anything outside of your host machine, then you might and you mostly will need a volume plugin. We also have the bind mount storage options, and the way this differs from Docker volume is that you could mount any path in the host to any path in the container, and that is something that you cannot do with Docker volumes. Docker volumes manages everything inside a dedicated path in the host, which is usually /var/live/docker/volumes and the name of the volume. But with bind mount, that is not the case. You can literally mount any path from the host. It could be a desktop, it could be a downloads folder, it could be anywhere in the host, and you can mount that specific path, that folder or file to a container path. So that is not restricted. The use case where bind mount can be really useful is mostly for, let's say, speeding up your development environment. So you could mount your current directory of your application whenever you are working, the source code directory, to a path in a container. So whenever you make any changes to your application source code files, that is instantly reflected in the container itself. So you don't need to build image every time and then run it. So you can, whenever you are dealing with the development purpose, you can directly make changes to your application files, and that will also be reflected in the container file system as well. So you can quickly check and come back again. So specifically used for debugging purpose and things like that. But whenever we are dealing with the production systems, it's highly recommended to use Docker volume instead of the bind mount, because whenever we use the Docker volume, the entire file system or the path where the files are stored is managed by Docker. So we do not need to worry about permissions, the lifecycle management of the data, such as the cleanup and all those things. That is all done by the Docker volume driver itself. But if we are mounting a random path on a host to a container, so we might need to deal with permission errors and things like that. And also cleanup and all those things really become difficult. So generally, it's recommended to use Docker volumes over bind mount whenever you can do that. And finally, we have the DMBFS storage options, and this is used to mount the RAM or the physical memory itself directly to the container. So if you have a use case where you need that fast read-write access, then you can use the storage options. But please be careful, because none of the data is actually stored in the host or any other external system. So all of the data that you might create or use will be gone whenever you stop the container. So this is just a temporary storage whenever you want to have that fast read-write access. Alright, so now let us jump straight into the demo. So the first thing that we are going to do is to list the containers, and you can see that we don't have any containers running at the moment. So now we are going to create a new Docker volume, and for that we are going to use the Docker volume create command, and we are going to name it as my volume. And you can see that the volume is now created. So if I do Docker volume ls, the volume is listed, and also the driver is local, as we just discussed, right? So this is a local volume driver that we have created. So now I will inspect the volume using the Docker volume inspect command, and you can get more details about the volume, such as the creation date, the driver, and importantly the mount point. This is the path where actually the data and the volumes content will be stored. So whatever we create or do in this volume will be inside this specific path. So that is about the docker volume inspect command. So the next thing that we are going to do is to run an nginx container, and you can see that we are trying to run the nginx container in the dtask mode using the -d options. The latest image for nginx is used, and we can specify the volume using the -v flag, and we can give a name for our volume that we just created. That was my volume, and after the colon we specify the container path where the volume should be mounted, and the container is now up and running, as you can see here. And now we can inspect the container itself using the container ID. So if I do docker inspect, under the mount options, I should be able to see the volume details. You can see the name of the volume, the read-write mode as true, and also the different path, as well as all the other details of the volume itself, right? So we have verified that our container actually uses that volume. So now let us go ahead and try to run a new container, and this time we'll see a new method of doing so. So we'll use the -mount option instead of the -v. But -mount is more verbose. That means that we can specify more options, and also it is clear to understand. So you can see that we have specified the source as my volume, which was created, and also the target as /data. We could have a lot more additional options as well, such as the read-write mode, read-only mode, and all those things. So now you can see that we have the two containers up and running. All right, so now let me go ahead and try to run a new container, but this time I will use the -v flag itself. So I just wanted to showcase you the different options of creating and attaching the docker volume. So we will use the -v, and this time I will mention the mode as RO, that is specified by the RO flag. That means that the volume would be read only. So we will check this whenever we execute inside the container in later states. So now if I do docker ps, you can see that I have 3 containers, 2 in the read-write mode and 1 is in the read-only mode. So let me try to execute inside one of the containers. So let us go and execute inside the first container. We'll open up the cell in that, and we'll go to the /data. So that was the path where we mounted the volume. If I do ls, we don't have any files. And if I now create a new file named hello.txt, let me try to add some quick data inside that file. So let's say hello from the first nginx, and let me echo that to hello.txt. So let me try to exit from the first container now. As we can see that we have successfully gotten the response. So now let me try to run the cell inside the second container. So let me try to execute inside that. Again, I will use the docker exec command, and I will use the -it for the interactive terminal mode, the ID of the second container, and I will go inside the cell. So if I now go to the /data path, remember the first container did not have any data, but if I do ls over here, we can already see the hello.txt, which we created from inside the first container. But remember how this is happening. All of this is happening because we mounted the same path and the same volume in both of the container. So the second container is using the data from the docker volume that we created and mounted to the first as well as the second container. So that is how they are sharing the data, and you can see how docker volume allow us to have the data sharing option. So you can see that I can add some additional data. Let's say hello from second nginx into hello.txt. So now that the file content is changed, so this will also be reflected in the docker volume. So if I now go back to the first container and try to list the file content, you can see that we still get the content that we added from the second container, right? So remember that both the container are sharing the same volume, and we have also mounted it on the same path. So whenever we make changes from one of the container inside that path, that is reflected in the docker volume, and any container that use the same volume will always have that data. And so that is why we were able to add and change the file from multiple containers, and all of them share the same data. So that is how docker volumes allows us to have persistent storage. So let's see this from a new angle. All right, so to test this more further, let us try to create a new container named as dev-test-new and try to do docker ps. You can see that the dev-test-new container is also up and running. And remember that since we mounted the same volume, the my volume also in this new container. So if you try to go inside this /data path and try to see the files over there, you can see that the hello.txt with all its contents, it's still there, because remember why? It is still mounted to the same volume that we used for the containers, right? So whatever changes we did from other containers, it is still reflected in this new container because it shares the same volume. And this shows a very beautiful way how docker volumes can be used to persist and also share the data among different containers. So let me try to exit from that. And now let me try to showcase you a use case where we can use the read-only path. So let us try to execute inside the container which uses the read-only mode. So remember that was the 2380 container. So that is the container which only has the read-only mount as the Docker volume, right? So if we go to /data and I can do ls-la to see all the file contents, so you can see that the root user has read-write access, but other users and group only has the read access, right? So that's the difference when we use the read-only mode. So let's say let's the hello.txt file, but let's say if I try to change the content, right? So if I do echo, I'm trying to edit hello.txt from the third container. So if I try to do this, I should be getting an error. So let us just check that. So yeah, there you go, that I cannot edit that because this container has that volume as read only. So we cannot make changes to the content. We can only read that. All right, so now let us see an actual use case of Docker volume in a more real application. So here I'm building a Node.js application. You can find the link in the description below for the GitHub repo. And this application utilizes the SQLite database. So it stores all the data in a single path itself inside a container, right? So we need to have some sort of volume for this container so that the data persists. Otherwise, we would lose that data. So in order to check this, let us first try to run the container. It runs on port 3000. You can see that we are running it in the DTAS mode on port 3000, and we are using the Docker image with the tag to run this. So remember that we are not using volume at the moment. The container is up and running. I can do docker ps to check that, and you can see that the port binding is successful. So I can quickly check that by opening my browser. And if I go to browser localhost port 3000, I should be able to see my to-do applications, which does not have any data at the moment. So let me quickly try to add some data. So let's say go to jogging, try to add that. Also, let us add by strawberries, right? So why not? So let me add that. So see that we have added 2 data. Let me delete that jogging one because I don't usually go to jogging. So you can see that the data is still there if I refresh it, but let's try to remove the container itself, right? So let us see what happens when we completely remove the container. So I have removed the container using the -f flag because we need to use -f when we want to stop the running container. And now if I do docker run again, remember that we are not using the volume option over here. So if I go ahead and check for that, you can see that the data is gone, right? So the data is not persistent because every time we create a new container, we have not addressed any volume. So that will not be persistent because Docker writes that in a temporary layer, which will be deleted once we delete the container. So that is not persisted. So now let us try to, create a volume and then attach that volume and see how we can use persistent storage. So I have created a demo DB over here. You can see that I can list that using the docker volume ls command, right? So now if I try to run the container first, let me stop that. So I will remove the container using the ID and the -f flag. So we need to remove that. But now if I run the container again, but let us try to use the mount option to mount the volume, right? So let us mount the demo DB to the target /etc/todos, and that happens to be the path where the SQLite writes the data inside the container. This might be different for your container image, but that's the path where the SQLite writes its data, right? So now, if I run the container, you can see that we don't have any data at the moment. So let us try to add some. Remember that the data that we added earlier, so that we were not using any volume, so all of those were gone. But now let us try to add 2 data, create YouTube videos and some demo tasks. And now let me try to, stop the container that was running, right? Or let us remove it itself. So I'll use the docker rm command and the ID of the container. I'll use the -f flag again. So the container is completely removed, right? But I'll try to run the container again. And again, you can see that we are mounting the volume this time. So if I do docker ps, that's a completely new container, right? But if I go to the port and access the container, you can see that the container data is still there because remember, the new container is using the same volume that was created and mounted to the first container, right? So that is how the data persistent works. So I hope that makes things clear. All right, so the next thing that I want to show you all is about the docker volume remove command. So please remember that whenever you remove your container, the volume will not be deleted automatically. So let's try to see that. Let us try to remove container with 7c ID. And you can see that the container is now removed, but if I do docker volume ls, the volume will still be there, right? So it's not like the volume will automatically be deleted when you remove the container. And for that, you need to explicitly use the volume rm command and give the name of the volume in order to remove that. So first, all the containers that is attached with that volume needs to be stopped and removed. And after that, you can remove the volume. So that confirms when I try to remove the my volume which was used and created in our earlier demo. So that is because it is already used by some of the Nginx container, right? So you can see that the container is still there. We created this container earlier when we saw the Nginx demo. So I can docker ps, you can see that the 3 containers that is using the my volume is still up and running. So that is why we are not able to delete the volume, because we might accidentally delete the volume, which might have some additional important data for the container. So that's a prevention use case. So I need to first stop the container using the -f flag, and then afterwards I can use the volume rm to remove the container, right? So yeah. All right, finally, let us try to see the use case of volumes in Docker Compose. So we'll talk about Docker Compose dedicatedly in a future video, but now let's just understand that Docker Compose is used to run multiple containers. So let's say for our application, we want to use the MySQL database instead of the SQLite. So we could use the MySQL image from the container community, right? So we can use that container image from the community, and again, it needs to store the data in a host or some other volumes, right? Because we need the database data to be persistent. So we can specify that under the MySQL service, and under the volumes, you can specify the name of the volume along with the path in the container where you want to mount that volume, right? We can see that we have created a volume named to MySQL data, and the path inside the container is /var/sleep/MySQL, and that happens to be the path where the MySQL stores its data inside the container. And you also need to specify the volumes separately, right? So under the service, we have the different containers. So if we have the app container and the MySQL container, we need to specify the volume that the MySQL container will use. And also to create a dedicated volume, we also need to specify it under the volume section on the same level as the services section, right? So that is what we need to do additionally. If you look here in the app service as well, we have one volume, right? But that is about the bind mount. So we'll talk about bind mount in a later video in detail. So that is basically mounting whatever the content is there in the source directory to the /app directory inside the container. So we talked about the dev environment build up, right? So that is what is happening in the bind mount over here. So let me try to do Docker Compose up to run all the containers, and you can see that it will create all the volumes, network, and everything that is required for the containers to run. So if I do docker ps, you can see that the containers are up and running, both the app as well as the MySQL container. And I can also check the volume. If I do docker volume ls, you can see that the volume is created, and the name is a bit different from the name that we specified in the compose, right? Because we specified in the compose as to MySQL data, but that is prefixed by the name of the folder where the Docker Compose file is located. So that is how it got the Docker node.js to do, and then the name of the volume that we specified in the Docker Compose file, right? So let me go ahead and check the content itself. So this is a new volume, right? So we go ahead and add some data. So let us try to add some random data over here just to check the validity of the Docker volumes, right? So this is from Docker Compose, right? So, and also I say hi there, right? So let us go ahead and now try to stop all the containers, right? So I will do Control-C to stop all the containers. And maybe I will do even compose down, and that will stop and remove all the network. But please remember that whenever you docker compose down, the volume is not deleted. So if I do docker volume ls, right, so you can see that the volume is still there, though the corresponding containers and the networks are deleted. So if I do docker ps, we don't have any containers, but the volume is still there. So if I do a compose up again, the new container and new network will be created, but that will be using the same volume as the earlier one. So if I go back to the site and do refresh, I'll still have all the data intact. And that is how Docker volume works in the context of Docker Compose. So I'll stop it again, and that is how it works. Again, please note that in order to delete the volume, so you can see that the volume is still there, right? So we need to delete the volume manually. So that won't be deleted when you do docker compose down. So for that, we need to have all the containers stopped first. Only then we can delete the volume. Remember that from the last demo we saw. So you can see that we cannot delete if we try to delete it as it is. So if I do docker ps today, we can see that the container is still running. So that might be using the volume in behind the scene. So first I need to do docker compose down. So now the containers and the networks are deleted. And now I will be able to use the docker volume rm command to delete all the volumes. Alright everyone, that was all about the Docker storage and more specifically the Docker volumes I wanted to show you all today. I hope you learned something about the Docker volumes and can use them in your projects and application. If you like this video, I would really appreciate that thumbs up button, and please subscribe to my YouTube channel as I plan to post regular videos around DevOps and cloud, making it super simple for you all. I've also started publishing blogs. So if you're more of a reader, then please check out my blog as well, which is linked in the description. Thank you and have a great time ahead. I will see you soon. Bye-bye.